Eyes down for the Morning folks, Monday, back on the Colchester. And I've managed, by putting the reamer into the Morse taper 3 reamer into the Morse taper there and cleaning it up, I've managed to get down to just under 2 thou runout at this end. Right now, I don't know if I'm going to improve that at all, but what I'm going to do now is I'm going to blue up that taper again, put that taper into the spindle and check it to see if I can find any more high spots. But that, I think that's tolerable, right? Put it like this: when I wind from there to there, right, I have 5 thou offset, so we know we can improve on that. So I'm going to blue that taper up, clean it all up, put it back together and see if I can improve that 2 thou any. I'll bring you back when I've done it. Bye now. Well folks, I think I might have achieved the best we're going to get. I've just given that I've given the whole spindle a really thorough clean out with a bit of fluffy cloth on the end of a steel rod. Gone right through it, sprayed it out with electrical degreaser. Then I blued it up and got a really good result, to be honest. But it just did show 1 or 2 high spots. So I just eased them down a bit with a scraper. Very minuscule removal. And look what we've got now. Less than half a thou. So I think for a Colchester student from the 60s, that's about what we're going to get. So now I can traverse along and see how far out the bed is to the headstock, which is what I'm going to do next when I've just moved some junk. Right. Whoops. It's about 5 thou. It's about 5 thou. In fact, it's just over 5 thou in that length. So we know we're a wee bit out. So the next thing to do is try and remember where the Allen screws are that hold it all together. Yeah, it's about 5.5 thou out. This is a half thou. Yeah, it's a half. This is a half thou per mark. Dial indicator. So that is moving. Let me just get this right. So it's leaning that way, so we have to move it. So next thing to do is to find the fixing screws. I'll bring you back when I've found them. Right folks, there's 1, 2, 3, and then the other 2 are under there. There's one, and there's one further down, but I can get into here from here, so they're not difficult to get to. So next thing to do is to get those slackened off. Now, on Colchester students, you will find all sorts of people will say, oh, I've got 2 screw threads in here that I adjust because there's a pivot, right? And this pivot you can use by adjusting the screw one way or the other. You can use the pivot to angle the head. Well, mine hasn't got that because mine's a really early wood apparently. Mine isn't the 1.5, it's the Mark 1 with the single lever for sliding and surfacing control that you go in the 2 slots with. So I'm going to take this gear off and I'll show you. Bring you back in a minute. Right folks, as you can see from that, mine has no dowel, no pivot dowel and no adjusting screws, but it does have clearance machined on the bed. So the next thing to do is to get those Allen screws slackened off and see if I can get it running straight. And you can see right through there, can't you, without the light, that there's actually nothing in there at all. Right, off we go. Right folks, so you loosen 3 Allen screws at this side and you loosen 2 Allen screws at the back, and then I got a piece of round bar, wrapped it in a cloth, pushed it into the spindle and gently eased it either way until we got this. Now it goes a little bit off, half a thou off right at this end, maybe a thou, but other than that it's rock solid. And for an old lathe which has got to have some bed wear on it, right, I don't think we can do better than that. I really don't. I'm happy with that, that's rock solid. So I've tightened the Allen screws up, and I must admit, I'm not going to lie to you, I use mole grips on those. I tried cutting down Allen keys, I tried all sorts, and the only way that that's going to be any good at all is with the front off, and I'm not taking the front off. So there you go. So just the 3 back ones to nip up and job's a good one. Thank goodness for that. And then of course put it all to put back together. Right, I'll bring you back when I've done it. No folks, you're not on the wrong channel. It's still me. It's Friday. Wednesday I was visited by Paul from Haxby Shed, and he very generously brought me a mug and a pen, and I've just made myself a brew in it. So thanks Paul, very generous. And today what I've decided to do, because Wednesday Paul came over and we spent the day larking about and having a laugh and looking at machines, etc, etc. Thursday was my birthday, so I had to stay at home for compulsory pampering, which was good. So what I thought I'd do to finish off the week was this. This is the 3-jaw chuck that I got along with all those other lathe bits over there for cheap. The 3-jaw chuck runs out, as all 3-jaw chucks run out. This runs out for a couple of reasons, mainly because the taper down there and here is badly knocked about, and if you actually put it onto the lathe and then tap it on the face with a rubber hammer, it actually improves. So we know that the taper is not seating properly. But what I thought I'd do just for an hour or two today is strip this chuck down and show you how they work, what goes wrong with them, and what you can do to put them right, which is virtually nothing, right? But you can make them better. You can make them better, and you can also, with a bit of faffing about, get good alignment even in a fairly worn 3-jaw chuck. The other 3-jaw chuck, these fit the Colchester. The other 3-jaw chuck on the Colchester was very worn, which had an error. If you put an approximately 3/4 inch round bar in the chuck, you had an error run out averaging about 17 thou, which is far too much, right? You expect on a brand new quality chuck, you would expect a run out of 3 to 4 thou, right? The 3-jaw chuck is not an accurate tool. The most accurate chuck you have is the 4-jaw, which you have to align yourself, but you can get it spot on, right? So what I'm going to do first of all is I'm going to strip this, show you how they work, but there's a rule. The rule is, before you strip anything, you check around the mating face to see if it's been stripped before, because if it has, it'll have a couple of witness marks on it, so that when you reassemble it in the same place, in the same orientation, right? So this, I've already checked around this and it hasn't got any, so the first thing I'm going to do is put 2 centre pot marks on it, right, one on either side, so we can get it back together. Then I shall loosen all these Allen screws off, get it apart, and then I shall bring you back and show you around it. Okay, bye now. And there we are, folks, separated. This is the scroll, which when rotated moves the jaws, and the first thing you see is the play on the scroll. Right, these 3 gears are where your chuck key goes in. I have put 2 witness marks on it, it didn't have any, right? And after I take the Allen screws out, I just carefully used a punch to tap on the backs of the rebates there until I got a gap wide enough to put 2 screwdrivers in opposite each other. Whenever you're separating anything or levering a bearing off, always try and use a lever at either side, not just one and then go to the other side. Then always use 2, because it will come off straight and it'll make your life a lot easier. Right, looking at the grease and the crud in this chuck, it's not been stripped for a long time, if ever, because I say, as usually, if they've been stripped, they've got witness marks on them, or they should have been marked so they go back together as they were originally assembled at the factory. Right, I'm going to give this a clean up, and the first thing I'm going to do is lift the scroll out. When I lift the scroll out, we'll be able to slide the jaws out. Okay, here we go. Right, folks, I've got the scroll out, a little bit of very careful tapping with a punch, and it seems to be very little worn. So if you strip a 3-jaw chuck, and the first things you must check for is the condition of the scroll. You've got to look very carefully around it and look for any worn areas or areas where the, let's call it a thread, where the thread has been forced over. Because remember, when you reach for that piece of pipe to put over your chuck key as a cheater bar, to just get that extra bit of tightness, what you're doing is you're forcing this round to squeeze that little bit further that way, right? And you're putting a lot of pressure on, a huge amount of pressure. This is why it's always important that chucks should be lubricated properly. Now this one has what looks like a grease nipple on it there, but I would say that it's an oil nipple, because I've never, when anybody ever says grease and lathe in the same sentence, they'll jump down your throat, because they say you never grease a lathe, you always oil it, because the oil doesn't hold the chips, whereas grease holds the chips, and it also holds anything else it can get its hands on, turns it into grinding paste, and grinds your beautiful precision machine surfaces to dust. Looking at this chuck, overall it's not very worn. So as I say, the first thing you've got to look for is little ridges and marks around here where the chuck's been over tightened and this possibly has been forced slightly over. The second thing you've got to look for is the fit of this surface here onto that surface there. Right? As you can imagine, if you've got 3 jaws in there like that, roughly, if this scroll ring is able to move slightly on there, if there's any play at all, when you tighten it finally up, it'll go like that. Very slightly, but it'll all add to the accuracy. Now, to my great surprise, this chuck, although it's got to be old, because this was taken off a Mark 1 roundhead student, just like mine, right? And I can't believe that it's this unworn. But the fit on there, on this particular chuck, seems to be very good, and it seems to have virtually no wear on it at all. And so, because this bears on the outside and the inside, right, the scroll is very precisely located so that it can't go like that or like that as you tighten the thing fully up. So I'm quite surprised. I expected this chuck to be worn and I will be able to demonstrate the wear to you, but as I say, it pretty much isn't. Now the jaws, what you have underneath the jaws is this, and you can also see there that they don't look to be particularly badly worn. You check 2 things. You check these for chips, damages and scrapes, striations on them, and you also check them for their fit in the chuck body to see if you can lift them up and down like that, because obviously if you can lift them up and down as they come up tight on something, if you've got something nipped in the outside of the jaws and you tighten it up, it'll try to tilt the jaw like that, right? And that way you strain the jaws at the inside and it becomes bell-mouthed. In other words, it becomes worn or strained in this part of the jaws. If you possibly can, always grip on the full width of the jaws. Now if you look at these jaws, look at the surface of these jaws. Let's get a close-up look. Look at the first square, this one here. You can see that that is slightly larger than the others. I hope you can anyway. It's slightly squashed, but all the others are pretty much square. Let's see if we can see that on the other ones. Yes we can. This is slightly squashed. This is why whenever you can, you should always use the full width of the jaw to hold your work. Make sure that your work goes right into the chuck. Right? And I mean, I know you can't always do that. It's one of these things that you compromise. But when you nip on the outside, very outside of the jaws, be aware that you are straining your chuck. Right? This is the only time. If you have a very unworn chuck and you can set the jaws up and put tension on them by putting spacers in between these surfaces here and put tension on it, you can then grind from front to back with a tool post grinder, and you can get that jaw, you can get rid of that little squash square and even it out all the way back. That's about the only time you're going to make an improvement. If you've got any wear on the jaws, or any wear on the scroll, or any wear on the way the scroll fits in the body of the chuck, you're largely wasting your time, because every time you take something out of that chuck and put something else back in, that scroll will be in a different position. Depending on the diameter, you'll be using a different part of the scroll. And if there's wear in there, every time you tighten it up, that scroll will shift slightly, the jaws will shift slightly, and the result is an inaccurate grip every time. And if you grind a chuck that's in that condition, you can only get it accurate for one diameter. So if you're gripping a piece of 3/4 inch diameter bar, and you get these jaws wedged firmly at 3/4 and you grind them, then it will grip a piece of 3/4 bar well, but it probably won't grip anything else as well, because in other places the inaccuracy comes back in. Now, as I say, this is in good condition. I'm amazed that this is in such good condition. So what I'm going to do now is literally give it a good wash out, oil it and put it back together. But first I want to show you something. I wonder if I might be able to, I'll have a go at setting it up and see what I can do. I'll bring you back. Just another note, on this type of chuck, the gears, the tightening gears, are held in with a circular key, which you can carefully pull out with a pair of pliers, or you should be able to anyway. I've got one out. It's like that, look. It's like that. On other sorts of chucks they have a stud that just puts its nose into there to locate them. So there you go, that's how you get the gears out. Take the circular key out. Right, it's washing it off time. Right, the other place we get wear is up and down play there, and to my amazement this chuck has hardly perceptible up and down play. In fact, this jaw is tight, but it is number 3 and it's got the right numbers on it for this chuck, so I gather there's something in there somewhere. But there's no perceptible up and down play, and there's very little side, well, there's no side to side either. Right, and this is a Pratt chuck, it's not a Pratt Bernard, so I'm just going to look up and see when it changed, see if I can get a date on this chuck. Right, I'll bring you back. Folks, I don't know how accurate this is, but this is a Pratt chuck, right, and Pratt acquired the assets of Bernard in 1954 and became Pratt Bernard. So I must presume that this chuck is possibly previous to 1954, certainly previous to 1960. So this is an old chuck, and yet it displays very little wear and almost very little use. Now, these companies did used to offer a service where they would take your old worn chuck and they would recondition it for you, and they gave up doing it because it was so difficult to make them accurate again that it was just costing them more than it was worth. And once a chuck is worn out, there isn't a great deal you can do with it apart from chuck it away and get another one. Right, I've got everything clean in some gunk, and I'm just going to blow the other bits off, and then I want to offer the back plate up to the lathe, tighten it on, and see if we can take a clock reading off the inner surface to see how far out it is on the taper. So I'll do that, I'll bring you back and show you. Right, I hope you can see better now what I mean about this taper being abused. Can you see all those dings in there? Right, I'm going to offer this onto the lathe now, and then I'm going to run the clock around that surface there and see what we get. Bring you back when it's in. So there we go, folks, and much to my surprise there is less than half a thou runout on that surface, and very little more on this surface. In fact, it's difficult to measure on there, but very little. So I must come to the conclusion that although that taper is badly fitted or badly marked and damaged, it's still fitting very accurately. I have tightened it up. What I'm going to do now is to give it a good thwack with a rubber mallet and see if I can take even that out, and then I'm going to glue the taper up and fit it again and see if we get any areas, any high areas on the taper in this piece, and if we do I can just ease them down with a scraper and then we'll get a better fit. If we can improve on this, to be honest, that is really quite an amazing bit of accuracy. Right? I really can't complain at that. I don't think it's probably not worth doing it. Probably not worth doing it. I think we'll leave it at that. I'll put it all back together. Oil it up, and then we'll see. Right, this may be difficult for you to see, but I have printed it. I have got some blue in there. Now as you can see, I've got heavier blue there, and we've got these light spaces where it's not touching. So those dinks that I've already relieved look like they're low, but if you look at the inside ring, there's still a few places there that could be high. One there definitely. So I'm just going to do some work on there, on the inner ring, and then I'll print it again and see what we get. Okay, I'll bring you back. Result, folks. I've just eased the little bits that I could see that were touching heavily, and we've now got contact all the way around, both inside and outside. Very pleased with that. Right, let's chuck it back on and see if we have reduced the almost non-existent run out anymore. What we know we've got is a better contact, and I think you'll all agree that that is pretty perfect. I don't think you can do better than that with a lathe of this age and a chuck of this age. That is just, that is just, as far as I'm concerned, bloody perfect. That little bit of movement could be just roughness on this surface, right? But it certainly isn't. It's not gliding out at all. Less than half a thou there. Much less than half a thou. I'm very pleased with that. That's close enough for me. And there's the scroll back in, turning beautifully freely on fresh oil and no play, which is a good thing. So next we need to assemble the three little gears into the top body of the chuck, put the keys back in, put the whole lot back together. It's not a difficult job, but I have stripped these and found them absolutely full of metal cuttings, full of swarf, grit, and you strip them and you rebuild them, you put them all back together clean with fresh oil, and they're just like a different chuck, and they're more accurate. You can always improve even a worn chuck by just stripping it and cleaning it, deburring it, and you can always get some improvement by carefully putting your work into the chuck jaws and then tapping the jaws that are low, tightening it up gradually bit by bit, and you can find that even a worn chuck you can get your work roughly centered. Remember, once your work is in the chuck, if you turn all the surfaces of that piece of bar, right, it doesn't matter, because the component you made will be in line with the bed of the lathe. The only thing that won't be in line will be the surface that is gripped in the chuck jaws and the surfaces you have turned, because that is where the inaccuracy in the chuck jaws will matter. So if you're turning every surface on your piece of work that you're making, it doesn't make any difference if your chuck's a little bit worn. And as I said before, even a brand new 3-jaw chuck will have 3 to 4 runout on it on a good quality one. Expect more on a lesser quality one. There we are. I'm rebuilding this with straight 30 hydraulic oil, which is what I shall oil it with. Right, I'll get the 3 gears assembled into the main body and I'll bring you back and put it together. Here we go, folks. Just putting the last of the semicircular keys in. Very satisfying. Now they're all free to spin beautifully like they weren't before. Excellent job. Right, we're ready to put it back together. And so folks, last but not least, we'll put the jaws in. So if I take you into there, you can see the start of the scroll there. So you go to slot number 1. Number 1, there's number 1. And you get jaw number 1, which I should have had ready. There's jaw number 1. You get the scroll just off. You put jaw number 1 in and push it until it picks the scroll up by turning the scroll that way. Right, you see it move there? So then we have to bring the start of the scroll round to jaw number 2, which is there. And then we have to take jaw number 2, which I should have had ready. We have to put jaw number 2 in, up to the scroll, and turn the scroll until it picks up jaw number 2. And then we wind the scroll, start of the scroll, round to jaw number 3, there. We put jaw number 3 in, and we pick up jaw number 3, like that. And there we have all 3 jaws working together, and with any luck they'll come together in the middle. Let's wind it in and see if they do. And there she is, folks, back on the lathe. Always use a chuck board, because otherwise you will drop the chuck and you will damage your slideways. You'll put dinks in them. There's some classic examples over there on that Holbrook where somebody's been using a hacksaw and they've made little nicks in the back of the bed there. Can't be helped. They're there now. You can't do anything about them. Right, I'm going to find a piece of nice round bar, put it in that chuck and put a clock on it and see what it's like. I'll bring you back in a minute. Right folks, this is a small piece of bar out of a printer, and about the closest I can get it to is about 7.5 thou runout. That's 5, that's 2.5, so it's about 7.5 thou runout on this size bar. Now I shall put a bit of bigger bar in and see if it's the same. Some chucks, you'll notice that by one of the sockets there'll be a little circle, or there'll be a mark of some sort. That indicates the socket that tightens the chuck most accurately, but it's not on all chucks, and it isn't, as far as I can see, there isn't a mark on this one. So there you go, there's my two index marks for reassembly. Right, I'll put a bigger piece of bar in and see how it's doing. Bring it back. Right, now we can see. So, bigger piece of steel, and we have 5, 10, 12, 12.5 run out. So as you can see, as the diameter you are holding changes, the accuracy of the chuck changes, because at different parts of its circumference the scroll is slightly different due to wear, strain accuracy of manufacturing, etc, etc. So that shows you clearly the limitations of a 3-jaw chuck. But with a bit of messing about, right, you can get these 3-jaw chucks accurate enough to produce accurate work. And if you need to be better than that, use a 4-jaw. Right folks, that's it for this week. So thank you all for watching. Thanks for subscribing. Thanks for Paul from Haxby Shed for coming over to see me. You'll be seeing that on his channel pretty soon, no doubt. It's a glorious afternoon. It's far too hot for me. And I'll see you all next week. Bye now.